Welcome to Real Civil YouTube channel. In this video, or I can say we are going to start a video series in which we are going to complete the beam analysis. Okay, that is from applied mechanics. So here in this first video, or we can say in the introductory video, we are going to cover two very important points. First one is the type of support, and second very important thing is type of loading. Okay, these two things we are going to cover, because if you know these two things, if you have the knowledge of the type of support and the type of loading, you can solve any beam. Okay, so that's why in this particular video we are not going to solve any problem, but we are going to cover the basics. Okay, so let's start without wasting time. We'll start with the type of supports. Okay, so there are basically four types of supports we study in the applied mechanics. Okay, so here I will write the name of support. Okay, next here I will show the sign of support. And in this third column we will see the number of reactions. Okay, we will study comparatively so that we'll have the knowledge of all the supports. Okay, so let's start from the first one, is the simple support. Okay, first support is a simple support. Okay, so we show this support just by an arrow. Okay, I think you all know we show the beam like this by an horizontal line. Okay, so this is the beam and the simple support is shown like this by an arrow. Okay, this is the sign of the simple support, and there are only one reaction. Okay, and the reaction is vertically upward. Okay, here we are assuming the sign upward, it may be downward. Okay, that we will see later, but remember, simply supported beam has only one reaction. When there is simple support, there will be only one reaction, and that reaction is upward reaction. We called it as a VA, RA, depending upon whatever name you can give it to it. Okay, this is the first support that we called it as a simple support. Second is a roller support. There are only four types of support, so listen carefully, see the video carefully. Second is roller support, and the roller support we show like this. Here you can, this is our beam, and okay, so this is the way you can show the roller support. There is one another method also, where like this there will be a beam and directly like this. Okay, some will represent the roller support in this way. Okay, now how many reactions? That is again a big question. So roller support has also only one reaction. Only one reaction, and that reaction is perpendicular to support. Okay, I will explain what is perpendicular to the support. So suppose this is the beam. Okay, this is the roller support and this is the point A. Then here there will be only one reaction and that reaction will be shown like this, perpendicular to this support. Okay, we can give the name VA. Okay, why I said perpendicular? What is the difference between simple support, roller support? Suppose this is again a beam and suppose you have a roller support like this. Okay, then here reaction will be perpendicular to the support. Okay, like this. So if we draw simply, this will look like this. Okay, means to this plane it will be 90 degree. This is our second thing, roller support. When we will solve the problems, we will come to know. Okay, let's move on to our, here again I will write here name of support. Okay, then next will be sign of support. And third thing will be number of reactions. Okay, so we have seen the simple support, roller support. Now third support is hinged support, or there is one another name, pin support. Okay, hinge support or pin support. How can we show this? Again, here we can show this support by two ways. First one, suppose this is your beam and simply a triangle. So this is the one way you can show, or there is one another way. Okay, this way also we show the roller support, hinge or pinned support. Okay, these are the two representations. Now the next question is how many reactions? So there will be two reactions. One reaction will be vertical and one reaction will be horizontal to the support. For example, this is the support, this is the beam, this is the pin support. Then reactions will be one vertical, one horizontal. Okay, direction may be up or down, left or right, that is the different thing. Okay, so this is our third support, and we are going to see the last one, that is fixed support. Okay, so the sign of support is like this, and this is your beam. So this is the sign of the fixed support. Now there are three reactions. Okay, remember there are three reactions to the fixed support. Which are they? Suppose this is the fixed beam, fixed support. Then at this point A, this is the fixed support. So at point A, there will be one vertical reaction, there will be one horizontal reaction, and there will be one movement. Okay, VA, HA and MA. Okay, simply you just need to know the sign of supports and how many reactions are there. Okay, so in simple support only one reaction, roller support again only one reaction but perpendicular to the support. Then hinge or pin support, this is the representation, and if this representation is there, then you can consider two reactions, and this type of support is shown, then we can call it as a fixed support, and there will be three reactions. So you have to know the name of the support or sign of the support and number of reactions. Okay, so this is the basic thing you need to know. Okay, in continuation with the type of support, we will cover again another point, types of beam. Okay, there are so many types of beams, and these types of beams are derived from the type of support. That means if the support changes, then the name of the beam will change. Okay, we'll cover it fast. First type of beam is cantilever. I will not go much detail, I will just show you. So cantilever means one end will be fixed and other end will be free. Just remember this end condition, you have to remember. In cantilever beam, one end is fixed, other end is free. So this called as cantilever type of beam. Second one is simply supported beam. Okay, simply supported beam is shown like this. We know the sign, you have to just show it. Okay, third one is one end hinge and other on roller. So just show this one end is hinge and other end is on roller. So this is again another type of beam. Then fourth one beam is there, overhanging. So this is very simple. Overhanging means you can show any support here, any support you can show. Here also you can show any support, and you just need to extend this part. Okay, this will nothing but the overhang. We know beyond the support, if there is any part, this part is called as overhanging. So we call this beam as a overhanging beam. There is one another type of beam, and that beam is propped cantilever. Propped cantilever. Again simple, you just need to know the end conditions, support conditions. So in that, one is fixed support and other is simple support. So here there will be simple support, here there will be fixed support. If this kind of situation is there, we called it as a propped cantilever. Okay, there are so many types of beam, but here we will finish. And this is continuous beam. Okay, so continuous means there will be more than two supports. Okay, you can show many, you can show anything like this. Okay, so these are the types of beam. And now we'll see again a very important point here, the types of loading. Okay, we will finish after this. Types of loading. When we will solve the problems, then we will go in the depth of the loads. But for right now, just remember, first one is the concentrated load. Simple. Concentration means at a particular point there is a concentration. So suppose this is the beam. Tell me in the comment box which type of beam is this. Okay, for type of loading 1, I will give the information of the concentrated load. So concentrated load is shown like this, P, or here there will be a value of 10 kilonewton, 20 kilonewton. Okay, comment me which type of beam I have shown for concentrated load. Okay, So next is uniformly distributed load. Okay. Again, comment me in the comment box which type of beam is I have shown for the uniformly distributed load. So uniformly distributed load is shown like this. Name itself uniformly means intensity will be same. Okay, suppose this is okay, forget this. So generally intensity is given like 20 kilonewton per meter or 30 kilonewton per meter or 40 kilonewton, anything, but unit is kilonewton per meter. So this is the uniformly distributed load. How to solve this we'll cover in the next lecture, but remember, whenever this is the sign, then this is the UDL. If this is the arrow is shown like this, then this is the concentrated load. Then third is uniformly varying load. Okay, now again comment me in the comment box which type of beam I have shown for uniformly varying load, and it is shown like this. Okay, some intensity will be written like this. How to solve we'll see in the next lecture. You just understand, if this type of representation is there, then we call it as uniformly varying load. You can see here uniformly distributed, here uniformly varying. Varying means changing. So uniformly the load is changing. Here uniformly distributed, load is uniform. This is the third type. And fourth type that is required for our syllabus is external movement. Okay, so just comment me which type of beam I have shown here. An external movement is simply shown like this. Its unit is 30 kilonewton meter and here unit is kilonewton per meter. Okay, so these here in this lecture, just understand, if this type of load is there, called it as a concentrated load. If this type of sign is there, called it as a uniformly distributed load. If this type of load is shown here, uniformly varying load, and external movement is shown like this. Okay, just remember these things. Okay, and comment me about this, which type of beam I have shown here. So in the next lecture we will solve the beam by using concentrated load, uniformly distributed load, uniformly varying load, and a moment. Okay, thanks for watching the video. Please like, share, subscribe the channel. Thank you so much.